The pounds formula. Perhaps one of the most useful and important formulas you will see as a water plant operator is the pounds formula. You will see it in at least two different forms, one in which you calculate pounds based on a volume of water, the constant 8.34, and the concentration or dose in milligrams per liter, or sometimes listed as parts per million. You may also see it listed as a result in pounds per day, which you get by multiplying a flow rate in million gallons per day times 8.34 times, again, concentration or dosage in milligrams per liter or parts per million. The pounds formula and its variations can provide the operator with the information to conduct a number of tasks. You can determine the feed rate in pounds per day for a given flow rate and dosage in parts per million or milligrams per liter. You can determine the amount of chemical needed to add to a fixed volume of water given the desired dosage. You can calculate the amount of chemical that was added to a given volume of water at a certain dosage. You can calculate the dosage of a chemical in a volume of water treated given the volume treated and the pounds of chemical added. And finally, you can determine the amount of chemical or substance present in pounds in a volume of water once the concentration in milligrams per liter or part per million is known. You will also see other variations of the pounds formula in your different practices as a water treatment plant operator. We will see those in later subjects in this course as well. Let us begin our discussion of the pounds formula with an example. In our example, we're going to determine the chlorinator setting in pounds per 24 hours to treat a flow of 5 million gallons per day with a chlorine dosage of 3.5 milligrams per liter. As you may recall from the Sacramento Manual example problems, we identified both our knowns for the equation we're going to use and our unknowns. Sometimes it's helpful to split them apart in order to help you to set up the equation. In our case, our knowns consist of our flow rate, which is 5 million gallons per day, and our desired chlorine dosage, which is 3.5 milligrams per liter. Our unknown, or the quantity that we're going to solve for, will be the chlorinator setting that we want to apply in pounds per 24 hours. So then, if we go through and we solve our problem, when we determine the chlorinator setting in pounds per 24 hours, we'll use the pounds formula directly in case we need the flow, the dosage, and our constant 8.34 pounds per gallon. Using our known values of 5 mgd, 3.5 milligrams per liter, and 8.34 pounds per gallon, we multiply all three parts together and come up with a final dosage or chlorinator setting of 146 pounds per day.